Hello everyone, welcome to our daily physics problem. Today, the first problem, we're going to look at cube A of mass m, supported by a smooth wall on the left and friction ground on the bottom. The coefficient of friction between A and the ground is mu, which is just enough to stop the cube from sliding. The angle between one of the sides of the cube is theta. Theta is smaller than 45 degrees, bigger than 0. We need to write a function to describe theta in terms of mu. So right now, I want you to pause the video, try on yourself, and then come back to it, and I will show you how I did it. So welcome back. Let's have a look. So clearly we need to balance the force here. So why don't we lay out all the force component on the graph? First, we have our old friend gravity. Then we have a normal force supported by the wall because it's contacting. Then because there's a sliding action happening, so we have a friction force against the motion of the sliding, and we have a normal force from the ground. Let's say this N2, and the force from the wall is N1. Well, first, let's balance the force component in the horizontal direction. First, we have N1 equals to F, because there are only two horizontal components and they're opposite to each other. Second, we have the vertical component balancing. We have the old friend gravity is equal to N2, which is normal force. There are only two components. The third, we need to balance the torque, because in order for object to be stationary, the horizontal, vertical, and torque have to be balanced perfectly. Let's say the torque is centered at a point wherever we can choose, as long as it's convenient for calculation. Let's say it's point B at this position. So now let's find our torque. I say the side length of the cube is L. Then we have N1 times sine theta times L is the first torque to the right. It's equal to the torque to the left, which is provided by the gravity. And we need to find its length of the arm which the force applied to it. So we find the point B to A, which is the arm the force exerting on, and we extend that to the opposite end of the cube, and we can calculate total length and divide by 2, which using Pythagorean theorem. L squared plus L squared, the square root, over 2, which is equal to L squared 2L squared, square root over 2, which is square root of 2 divided by 2 times L. And that will be the length from A to B. So we have mg times sine of 45 degree minus theta. Why is that? Because if you imagine the cube is in vertical, the angle should be 0. But now because it's a little bit tilted, so whatever the angle it tilts, shifting from the original angle, which is 45 degree, it will be the angle between the force component and AB. So now we have all the system equations that we can list out from the force balancing and the balancing of torque. Now let's try to solve it. From the first, we see N1 is equal to F, which means N1 equal to N2 times mu. And then we can find expression for N2, which is equal to mg. Then we plug in M2 into the original equation for N1, which means N1 is equal to mg times mu. Then we plus N1 into the third equation for the torque. Let's get N1 times sine theta L equal to mg times sine 45 degree minus theta. Oh, we also need to times the lever arm, the square root of 2 over 2 times L. Then we have mg mu sine theta times L equal to mg sine 45 degree minus theta times the square root of 2 minus by 2L. Cancel out the components, and we have our mu times sine theta equal to sine 45 degree minus theta times the square root of 2 over 2. Now we only need to simplify the equation. So mu sine theta is equal to, let's use some trigonometric identity, the sine angle subtraction, which is equal to sine 45 degree times cosine theta minus cosine 45 degree times sine theta. And all of it times the square root of 2 over 2. Now let's simplify furthermore. We have mu is equal to sine 45 degree, which is square root of 2 over 2 times cosine theta divided by square root of 2 over 2 times sine theta times square root of 2 over 2. And we mu is equal to, let's factor out the square root of 2 over 2 times the square root of 2 over 2. We have 1 over 2 times the cosine theta minus sine theta. Oops. Oh gosh, I forgot the sine theta. Forgot to divide both sides by sine theta. Okay, right now we have our simplified equation. But it's not simple enough. Mu still equal to cosine theta minus sine theta divided by 2 sine theta. Then we divide by both sides of the right side equation by sine theta. We have cosine theta divided by sine theta is cotangent theta minus 1 is equal to 2. Divide by 2. So 2 mu plus 1 is equal to cotangent theta. Then cotangent theta is 1 over tangent theta. So tangent theta is equal to 1 over the 2 mu plus 1. Then theta will be equal to the arctangent of 1 over 2 mu plus 1. And that will be our final answer.